All right, today we're going to put on our detective hats. We're about to become geological investigators on a mission to solve a huge mystery, one that was literally written in stone millions and millions of years ago. You see, the Earth has these incredible stories to tell, but it doesn't use words, it uses rocks and mountains and canyons. And our job is to learn its language. So, you ready? Okay, let's dive in. You know, every great investigation starts with a puzzle, right? A question that just makes you go, And our puzzle today is a real head-scratcher. It's a mystery that's not just old, it's ancient, carved right into the landscape of the American Southwest. This isn't your typical whodunit. It's more of a how to do that. How in the world did nature create something so strange and, honestly, so beautiful?
Okay, just look at this thing. It's incredible. This formation is called Checkerboard Mesa, and you can find it in Zion National Park in Utah. The mystery is just staring us right in the face, and it's a big one. How did this massive chunk of rock get these amazing crisscrossing stripes? I mean, you can see two kinds of lines here, right? You've got the horizontal ones, kind of like layers in a cake, but then you've got these other lines, the angled ones, that slice right across those layers, creating this wild checkerboard look. It's almost like someone drew on it with a giant ruler. What could possibly create a pattern like that?
Well, every good detective needs clues, and our first one comes from looking really closely at the rock itself. Geologists have studied this thing, and they figured out what it's made of. It's sand. Billions and billions of tiny little grains of ancient sand, all packed and glued together over a crazy amount of time. That's why they call it the Navajo sandstone. And this isn't just one rock. It's part of a huge layer of rock that stretches across multiple states. So knowing it's made of sand is a great start. But that still doesn't explain those stripes, does it? Knowing the ingredient doesn't tell us the recipe. For that, we need a special kind of tool.
To crack this case wide open, we have to think like a geologist. And geologists, well, they have a secret weapon. It's not a magnifying glass or some high-tech scanner. It's a powerful idea, a kind of secret code that lets them look at a rock and read its history like it's an open book. Seriously, this is the key that unlocks pretty much all of Earth's ancient secrets. And here it is. This is the secret code. The present is the key to the past. Now, it sounds simple, almost like something you'd see on a poster, but this is one of the most important ideas in all of science. What it means is that the things we see happening on Earth right now, like waves crashing on a beach, or rivers carving out valleys, or wind blowing sand, they all leave behind a certain kind of evidence. And if we can understand that evidence today, we can find the exact same evidence in ancient rocks and know it happened millions of years ago.
This amazing idea has a big, fancy scientific name: Uniformitarianism. But don't let that word scare you. It's actually a really simple concept. It just means that the basic laws of nature have always been the same. Gravity worked the same way a billion years ago. Water has always flowed downhill. Wind has always been able to move sand. Think of it like this. Imagine you come home and find muddy footprints in the kitchen. You weren't there to see it happen, but you know exactly what happened, right? Someone with muddy shoes walked through. You know that because you understand how muddy footprints are made today. Uniformitarianism is just taking that same logic and applying it to the whole planet.
So who was the master detective who first figured this out? His name was James Hutton. He was a Scottish geologist living way back in the late 1700s. See, back then, most people thought the Earth was only a few thousand years old. But Hutton was a farmer, and he was a patient guy. He'd watch the soil from his fields slowly wash into the rivers. He saw those rivers slowly cutting through solid rock. And he had this brilliant thought. What if these super slow, kind of boring processes went on for not just thousands, but millions and millions of years? He realized that given enough time, these slow processes could build entire mountains. This idea completely changed science, earned him the title Father of Modern Geology, and gave us our #1 tool for this investigation.
All right, detectives, let's do a quick recap. We have our mystery, those crisscrossing stripes. We've got our first clue, the rock is made of ancient sand. And now we have our ultimate detective tool, the idea that the present is the key to the past. It's time to head back to the scene of the crime and finally crack this case.
Okay, so let's apply our tool. We're going to stop looking at the ancient rock for a second and just look at the world around us. Let's rephrase our question. Instead of asking, how did this ancient rock form, let's ask, what process happening on Earth right now creates crisscrossing layers in loose sand? Think about it. Where do you see giant piles of sand being shaped into patterns today? Maybe at the beach or, in a desert. We're looking for a modern-day match for our ancient clue.
And here is our answer. Not too far from Zion National Park are the coral pink sand dunes. And what we see here, well, this is our smoking gun. When wind blows across a desert, it creates these massive waves of sand called dunes. Here's how it works. The wind pushes sand up the long, gentle side of a dune. When the sand gets to the very top, the crest, it just tumbles down the other steeper side. That creates a single, angled layer of sand. But, and here's the key part, the wind doesn't always blow in the same direction. So when the wind shifts, it starts building a new layer on top of the old one, but at a totally different angle. Over years and years, with the wind changing all the time, you get this beautiful, complex pattern of crisscrossing layers. Geologists have a name for it. They call it crossbedding.
Now for the big aha moment. Let's put our clues side by side. On one side, we've got the past, the Navajo sandstone, solid rock with these super distinct crisscross layers. On the other side, we've got the present, modern sand dunes, where we can literally watch the wind creating the exact same crossbedding patterns in loose sand. The patterns are a perfect match. So, using Hutton's big idea, if the result looks the same, the process must be the same. And with that, case solved. The Navajo sandstone isn't just some striped rock, it's a fossilized desert. It's a snapshot of an ancient world. Those horizontal lines, they represent different periods of time. But those crisscrossing stripes, they are the ghostly outlines of enormous sand dunes that marched across this landscape when the dinosaurs were still around. Each angled layer is a permanent record of which way the ancient winds were blowing, frozen in time. The whole checkerboard is like a weather report from the Jurassic period. How cool is that?
Now, what's really amazing is that our detective tool, this whole present is the key to the past thing, it doesn't just work for sandstone. It's not a one-trick pony. Once you get it, you start seeing clues to Earth's incredible history absolutely everywhere you look. It's like you've been given a new pair of superpower eyes.
For instance, how do we know where an ancient volcano used to be? We look for dark rocks filled with tiny holes, which looks exactly like the lava we see cooling in places like Hawaii today. Those holes are fossilized gas bubbles. How can we map a river that dried up ages ago? Well, we look for rocks made of smooth, rounded pebbles all stuck together, because the only way to get rocks that round is for them to tumble in flowing water, just like in a modern river. We can even find old oceans. When a geologist finds a thick layer of limestone, a rock made from the shells of tiny sea creatures, on top of a mountain, they know that mountain peak was once at the bottom of a warm, shallow sea.
And that really gets to the main idea here. The crucial point is this. If you can watch a process happening today, you can learn to recognize its unique signature. A river leaves a signature of rounded pebbles. A volcano leaves a signature of bubbly rock. A sand dune leaves that signature of crossbedding. And once you know that signature, you can spot it in rocks that are millions or even billions of years old and know, with a ton of confidence, exactly what that place used to be like.
So that brings us to the final thought. Now that you have this powerful detective tool, what stories are the rocks and hills telling you right in your own neighborhood? The next time you see a road cut with layers of rock or find a weirdly shaped stone in a park, ask yourself, what process happening today could have made this? The clues are all around you. The present really is the key to the past. What mysteries are waiting for you to solve? Thanks for investigating with me today.